Welcome to this tutorial. I'm glad you're joining me. In this tutorial, we're going to learn how to fade a light emitting diode. So instead of just blinking it on and off, it's going to fade in and fade out, fade on and fade off, over and over and over. It looks really cool. Now, okay, I know that sounds pretty simple, but let me tell you what, you're going to learn a lot of stuff in this tutorial. First thing, you're going to learn analog write. That's going to show you how to manipulate your digital pins so that you can get output that you might typically think of as analog. And also we're going to learn about the if statement, which allows us to control when things happen. It's extremely powerful, and it's really bread and butter of all programming languages. So lots of stuff to cover. Let's go ahead and dive in. All you need for this tutorial is an Arduino board. I use an Arduino Uno, but you can use any Arduino clone or derivative that you like. However, I do recommend actually sticking with the Arduino brand for these tutorials, that we know we're on the same page. You're also going to need a 220 ohm resistor. That's going to be red, red, brown on the markings. You'll need a light emitting diode, doesn't matter what color. And then to attach the two together, you're going to need either a solderless breadboard or you're going to need a little alligator clip. Now to set up the circuit, all you have to do is take either end of your resistor and put it into pin 9 on your Arduino board. And then take the short end of your LED, the short leg there, that's the cathode, and put it into ground. And then connect the remaining two legs with that alligator clip, or conversely you could put them into a solderless breadboard. And then you can go ahead and plug your Arduino in. So go ahead and open up your Arduino IDE and go to File, Examples, Basics, Fade. Alright, let's start taking a look at this sketch. Alright, so there's a couple big blocks of code. The first big block of code that I want to look at are the comments. Now it names what this function does. It talks about how to set up the circuit, and then it lets us know that the code is in the public domain so we can use it how we want. So there's the comments. Again, highly recommend reading the comments every time you're jumping into a new sketch. So the next block of code we come down to is where we declare and initialize variables. We've got 3 variables here. Alright, so we're moving up to more complicated programs. Usually there's just 1 or 2. Now we've got 3. Now they are all integers, which, those integers are pretty straightforward, so that keeps it nice. And they've got names that are very descriptive, which is an awesome thing. It makes me love them. So the first one is LED. It's equal to 9. So, well, what do we think that is? Well, guess what? It's the LED that we just hooked into pin 9. So we're referencing the pin number that we have our LED in. The next one is brightness. We've got set equal to 0, and notice how the comments on the side say this is how bright the LED is. So brightness is going to track for us the relative value of the brightness of the LED. And then the last variable is fade amount. That is set equal to 5. And again, if we read the comments there, it says how many points to fade the LED by. So fade amount is basically going to adjust the rate at which the LED fades on and off. So there is that block of code. So let's move on to the next block of code. That's void setup. So setup, again, it only runs once. It's used to set up the sketch. And if we look inside here, there's only one statement, and it's our old friend pin mode. Alright, so if you recall, pin mode takes 2 arguments. It wants to know a pin number, and then it wants to know what the mode of the pin is going to be, either input or output. This should be familiar to you. We haven't used it in a couple tutorials recently, but so just again, a quick reminder, it takes 2 variables. It takes 2 arguments. The first argument is what pin number. Here we've got LED, so that's pin 9, where our LED is attached to our Arduino board. And then the second argument is the mode. Do you want it to be an input or an output? Well, we are illuminating an LED. We want to apply voltage to this pin, so we want that pin to be an output. Alright, and that's all that goes on in setup. So before we jump into the loop function, let's go ahead and talk about the analog write function. Alright, so analog write is something you'll be using a lot, so it's important to get to understand. So first off, analog write has nothing to do with the analog pins on the Arduino. That was a little confusing for me at first. I thought, that's how you would write to your analog pins. But analog write, really what it does is it's used to invoke pulse width modulation. Okay, so pulse width modulation, which we'll talk about momentarily, basically allows you to adjust the power output of one of your digital pins. So you can use analog write on pins 3, 5, 6, 10, and 11 on most Arduino boards. And again, the board is marked on the digital pin that it can be used at. It takes two arguments. First, it takes the pin number, so that's the first argument you pass. So any one of those numbers that we just talked about. And then the next thing it takes is the value. So, well, what is this value? Well, this value is either 0 or it's 255 or it's somewhere there in between. And it is representative of the amount of voltage that's going to be output at that pin. So if you write 0, then ground voltage is going to be at that pin. And if you write 255, 5 volts is going to be written at that pin. And if you write anywhere in between there, then the amount of power output is going to be adjusted. Now, I use these words loosely because actually what we're doing is we're changing the duty cycle at that pin. So let's go ahead. I've got a schematic here. We'll pull this up and talk about duty cycle and pulse width modulation. So what is pulse width modulation? Well, all we do is we adjust the amount of time that 5 volts is being applied at the pin. So we're either going to have 5 volts or 0 volts, but we're going to adjust the frequency at which that voltage is applied. So let's look at this first graph up at the very top. You see we got 3 different graphs here. So the red line represents the timing, okay? And for now, just consider this arbitrary timing, okay? And the black line represents the voltage. So it's a voltage step that's being applied at the pin. So it's either 5 volts or 0 volts. There's no 3.3 volts being applied. Again, it's either 0 or it's 5. So it's going to step from 0 up to 5 and then 5 down to 0. Now, if you notice the first one, in a given time section, there's only 5 volts being applied 25% of the time. So that would be a 25% duty cycle. And in analog write, so remember we said the range was 0 to 255. If you divide 0 to 255 by 4, 25% of that would be 64. Okay, so if we do an analog rate of 64, we're going to get roughly a 25% duty cycle. And you can see that 25% of this arbitrary time, that pin is high at 5 volts. Now, what if we did an analog rate at 127? So now we look down at that next graph there. So we can see 50% of the time, 5 volts is going to be applied at the pin. The other 50% of the time, it's going to be 0. So this would be a half duty cycle, 50% duty cycle. And then what about a 75% duty cycle? Well, that'd be analog rate 191. And then we've got 5 volts being applied 75% of the time, and 0 volts being applied the other 25% of the time in that given time period. All right, so if you have a 0 duty cycle, well, then basically you're writing the pin low, so you're not going to have you're not going to have 5 volts being applied at any point in time. And then if you write an analog rate with 255, now you're setting the pin high, and it's going to be at 5 volts the entire time. So by adjusting the duty cycle, the on and off time of the voltage that's being applied, we can adjust the power that is being seen at that pin. Okay, so that's how it works. It's pretty cool. There's a lot more to it than my cheesy explanation, and there will be more about it to read in the further reading section. But for now, I think that's good enough for us to move on and do some cool stuff. So let's go ahead and jump into the loop function. Just as a reminder, loop runs over and over again, and it's really the meat and the potatoes of most of our sketches. So the first statement that we come to is our new friend, the analog write function. And here we pass it 2 arguments. We pass it LED, which is pin number 9, and we also pass it the brightness variable, which we set as 0. So what is this telling pin 9? This is saying, hey, we want you to have a 0 duty cycle applied at pin 9, which basically means there's going to be no voltage being applied at all. So the LED is going to be dark. So the next statement we come to is we adjust the brightness. Okay, so what do we have? We have brightness equals brightness plus fade amount. Now, is that a weird statement or what? You know, brightness equals brightness plus fade amount. So what's happening here? Well, we are taking our variable brightness and we're adjusting it. Basically, we're saying it is equal to its current value, which is 0, and then we add fade amount. Well, what was fade amount? Fade amount was the number 5. So the first time we run through the loop, this is going to be 0 plus 5. So what is the new value of brightness? Well, it's going to be 5. Now what about the second time we come through the loop? Well, the second time we come through the loop, brightness is set to 5. So then it's going to be 5 plus 5, which is fade amount, and that's going to be 10. So what will it be the third time we come through the loop? Well, brightness is now equal to 10, so it's going to be 10 plus 5, which is 15. And then the next time through the loop, 15 plus 5, 20. 20 plus 5. You kind of get the gist here. Alright, so that is how we are going to increase the brightness in a slow fashion with our LED at pin 9. We're going to slowly add to that fade amount. Okay, so we're just basically going to fade in from 0 all the way up to 255, which is the 100% duty cycle at our analog write. What happens when we get to 255? Because if we keep writing past 255, like we talked about before, analog write, the argument you can pass is from 0 to 255. So what happens at 255? Well, the short answer is we don't want to know, because we want to send analog write the correct numbers. We don't want to go outside of the range, because we could get an error, or it could just do something funky and we don't have any idea what it would do. So what are we going to do to stop this? So we need to set some type of condition in our program that basically says, hey, if brightness gets to 255, let's go ahead and reverse the sign on fade amount. So we're going to start, so once it gets super bright, well, let's start making it less bright. Let's, instead of adding 5 to the brightness variable, let's subtract 5. So basically all we have to do is change the sign of fade amount. And now, well, what happens when fade gets down to 0? We don't want to pass negative numbers to analog write, because again, the range for analog write is from 0 to 255. So we don't want to send it like -5. So we'd have to set another condition that says when brightness is equal to 0, go ahead and start adding 5 again. So one easy way to do that is just to switch the sign on the fade amount variable when we get to either 255 or 0. So if we get to 255, make it a -5, fade amount that is, and if it gets to 0, make it a +5 for fade amount. So how would we set a condition like that? Well, one way to do it is to use an if statement. So let's go ahead and take a look at an if statement. An if statement has 3 major portions. So the name of the function, if, that's easy enough, and then open and closing parentheses, and this is where you put the condition. So if the condition of your if statement is met, that is, if it's true, it's going to execute the code inside the curly brackets. And the curly brackets are the last major portion of your if statement. So you've got the name of the function, the condition inside the parentheses, and then the code that gets executed inside the curly brackets. So if your condition is met, it's going to execute that code. If the condition is not met, if it's not a true statement inside of that parentheses, then nothing's going to happen. The program's going to skip right over the if statement like it wasn't even there. So what do we have here? What is the condition that we set here? Well, actually we have 2 conditions, but let's look at the first one. The first one is brightness equals 0. So that equal sign is called a comparison operator. And what it does is it asks, are these 2 values equal? So why don't we just put an equal sign? Well, we'd be in trouble if we did that, because then the program would think that we're trying to assign our variable brightness to the value 0, but we're not trying to change the value of our variable brightness. We're just trying to compare it to another value, and that's why we have to use a comparison operator. Now what's our other condition? Well, you might guess it's, hey, is brightness equal to 255? Again, we use that equal sign for our comparison. Now there's those 2 parallel lines in between those 2 conditions, and that's called a Boolean operator, okay? And basically what it means is or. So if brightness is equal to 0, or if brightness is equal to 255, then do the following stuff. So that's our condition. If brightness is equal to 0, or if brightness is equal to 255, do the following stuff. Okay, so now there's also other Boolean operators, and you can also check out those in the further reading. So again, if these conditions are met, that is, if they're true statements, so if brightness in fact does equal 0, or if brightness does equal 255, then the code's going to execute it. Well, what's the code? So this is a clever little piece of code, and what I need you to do is on the right side of that equal sign, where it says fade amount, instead of just seeing a negative there, I want you to visualize a -1 multiplied times fade amount. Because what this does is it takes fade amount, which in our case is a +5 right now, and it multiplies fade amount times a -1. So what's 5 times -1? Well, it's -5. So what happens now is fade amount goes from being positive to being negative. And so now, if you remember that first statement in our loop, brightness is getting combined with fade amount. So if fade amount's -5, it's going to start subtracting from brightness. So it's going to start bringing 255 down in 5-step increments, all the way until brightness is equal to 0. And then our if statement is going to get executed again, because brightness is equal to 0, and it's a true statement. And what's going to happen? Well, fade amount, which is now -5, it's going to get multiplied by a -1. So what's -1 times -5? Well, two negatives make a positive, so now fade amount is going to become +5. And now when we go through our loop, that first statement is going to start adding 5 to brightness. So now 0, where brightness was at, is going to be 5, and then 10, 15, and it's going to keep stepping up. Now notice that the only time this if statement gets executed is when brightness is equal to 0 and when brightness is equal to 255. Anytime brightness is in between, so the LED is like not off and not fully on, this if statement will never get run. So if brightness is 10, if brightness is 100, if brightness is 245, it's never going to get executed. It only happens at those extremes, at the condition that we set. So that's an if statement. All right. So we're gonna run into lots more if statements in this course. So this is just your primer. So if you don't totally get it yet, don't worry. We're gonna, like I said, work with it a whole lot more. All right. So we've worked through the if statement. So now what comes after that if statement? Well, what do? We delay for 30 milliseconds. Now why such a big delay there, 30 milliseconds? Well, I guess 30 milliseconds isn't that much, but usually we're used to seeing those 1 millisecond delays. So the deal is the microcontroller is going to work really fast. And if we don't delay in between each of these steps, then we're not even going to notice that it's dimming. It's not going to be as apparent unless we delay a good bit amount of time. So that's why we've got the 30 millisecond delay. So once that's finished, we go ahead and jump right back into the loop. So let's go ahead and just do a quick recap of the loop. First thing we do, analog write. We're going to write LED, which is pin 9. We're going to write the value, the current value of brightness. Then we're going to go through, we're going to adjust brightness. We're either going to be adding 5 or subtracting 5 based on the sign of the fade amount variable. And then we're going to check the conditions of the if statement. So if brightness has gotten all the way to 255, we're going to change that fade amount sign. If brightness has gotten all the way back down to 0, we're going to change the sign of that fade amount variable. If it's not, if that's not the case, we completely skip it. We delay our 30 milliseconds, and then we go back and write the next brightness level. Okay, so you can see it dims up, it dims down, it dims up, it dims down over and over and over again. So let's go ahead and verify the code, and let's upload the sketch. And now let's go ahead and take a look at the Arduino. We should see our light dimming on and dimming off. Well, there you have it, a fading LED. So we had to learn a lot to do this. We had to learn about pulse width modulation using analog write, and we had to learn about an if statement, which is, it's kind of a complicated matter. So I'm glad you went through this tutorial. Thanks so much for listening in. Make sure you do the challenge. That's where that's really going to help sink this stuff in. So until next time, we're done with the basics section, moving on to bigger and better things. See you there.
you.